MIDI, beyond the 50-foot limit and its applications with Lightwave's MIDI extender products. In 1983, the introduction of a new digital communication standard for musical instruments called MIDI allowed keyboards and other electronic musical equipment to synchronize and communicate with each other. This was an incredible breakthrough for musicians, and if we look back at music history, had a major impact on the way music was written, recorded, and performed. The advent of MIDI shaped the sound of the radio airwaves in the 80s, and in turn made the songs you hear on the radio and the performances of artists you see in concert possible. In 2011, not much has changed except for trends in the style of music being recorded and performed. However, MIDI still remains the core of the electronic musician's setup. In its most basic use, MIDI can be used to trigger sounds from one electronic instrument to the next, or to synchronize a sequencer and recording device. Typical examples of MIDI equipment would be synthesizers, keyboard controllers, drum machines, sound modules, sequencers, and effects processors. Even guitar amplifiers, tube and solid state, commonly are equipped with MIDI, giving guitarists the ability to switch multiple devices simultaneously, like changing the channel of your amp and the effects processor presets with the push of one button. The MIDI protocol is not only limited to musical equipment, but is also widely used in theatrical lighting systems for concerts and shows and has many industrial applications that we are learning about every day. However, the MIDI specification calls for a maximum cable length of just 50 feet, and when MIDI signals need to be distributed over longer distances, such as in an arena, 50 feet can be a serious limitation. With conventional MIDI cables, any longer cable length could cause corrupted MIDI data or intermittent signals resulting in notes not triggering, sequencers not starting, channels not switching, or missed or wrong notes being played or not during sequences, which during a concert or performance could be a major disaster. Well, luckily, there is a solution, and today I'd like to introduce you to the MIDI extender product line from Lightwave Inc., which consists of the MIDI 1001 and MIDI 2001. Both units will extend MIDI signals far beyond the standard 50-foot limit and are the answer to error-free long-distance MIDI data distribution. If you've been searching for a way to run much longer MIDI connections with error-free transmission, then you're in luck. The MIDI 1001 extends your signals up to 1,000 feet using standard Cat5 cables without any interference or loss of data, and the fiber optic MIDI 2001 will extend signals up to 1 mile or more, again without any interference or loss of data. So how does it work? Well, without getting overly technical, here's what's happening. The MIDI 1001 Cat5 system takes the standard MIDI current loop signals and converts them into carefully balanced voltage signals. These signals are then conveyed between the various MIDI units by the interconnecting Cat5 cable. This results in error-free transmission over distances of up to 1,000 feet. How about the fiber optic-based system? Okay, here the standard MIDI signals are converted into pulses of light, which are then sent through fiber optic cable. Since the fiber optic cable is virtually immune to electrical interference, it can be routed wherever convenient without regard to the proximity of electrical noise producers, water or high voltages. In addition, since fiber optic cable is totally non-conducting, ground loops which can result in loss or corruption of data are virtually eliminated.